we're going to do more factoring, and you guys warmed up with some special patterns. So notice here that 144 is a perfect square. So when you're factoring this, it's going to be y plus 12 times y minus 12. The order that you write those in doesn't matter. So if you had y minus 12 and then y plus 12, that is okay. Now, notice that 49 and 36 are perfect squares as well. So you guys probably did a nice job of knowing that this was going to be 7 and 7. But we don't have h squared. We had h to the 4th. So h to what power times h to what power is going to be h to the 4th. Can't just be h and h. You have to have h squared. So h squared times h squared is going to be h to the 4th. Okay, here you have minus 36g squared. So again, you take the square root. One of them has to be 6g. One of them has to be negative 6g. Notice that 1 and 2 are both binomials. Anytime you have binomials, you're either going to have a GCF that you can take out, but there is no greatest common factor in 1 or in 2. So if you can't factor anything out, check for that difference of 2 squares. Okay, so both of these are the difference of 2 squares. Okay, so notice that for number 6, it's asking you to write 3 difference of squares. Okay, and then I'll give you an example, and then you can come up with 2 of your own if you haven't already. So when you have the difference of squares, you just have to have 2 perfect squares in there. So you could have something like 4x squared minus 9, and then that would factor into 2x plus 3, 2x minus 3. Okay, so this would be a difference of squares and their factored form. So you have to come up with 2 more, okay? All right, and then if you haven't done number 3 yet, can you try that? That is going to be a perfect square trinomial. We'll go over this together, and then I'll give you some time to write the other ones down. So in a perfect square trinomial, it starts with a perfect square and ends with a perfect square. The square root of 4t squared is what? 2 what? T. So it's 2t and 2t. And then the square root of 121, 11. And then you can see what the sign is based on what these 2 signs are. So this tells you the signs have to be the same. This tells you they both have to be plus. And then you can always check with FOIL. So inside you'd have 22t, outside you'd have 22t, and that adds up to 44. So when you're trying to write those yourself, there is a special pattern. If you multiply 2 and 11, 44 is just double that. So it's always the first one squared, the last one squared, and then double the product. So squared, double the product, squared. And then if you want, for 7, it says to write 3 perfect square trinomials. Okay, if you want, you can come up with the factors first, and then you can write your perfect square trinomial. It just has to be the same thing. So what if we did 6y minus 4 and 6y minus 4? And then we got to start recognizing the pattern. So 6y times 6y would be 36y squared. Remember, this is just double of the product. So if 4 times 6 is 24, negative 24 doubled is negative 48. And then negative 4 squared is positive 16. Okay, so I want you guys to fill the rest of those out. So come up with a couple of your own. Okay, so today we're going to extend factoring into solving by factoring. If you didn't finish your warm-up, you will have time after your notes to do it, okay? So when you are solving by factoring, you can use what is called the zero product property. This only works though if you have the quadratic equation equal to 0. So it needs to be equal to 0. So when you're solving, a lot of times you are going to have to move everything over so that it is equal to 0. And the zero product property says if A times B equals 0, then one of two things has to happen. Okay? If two things multiply to 0, what do we know about one of these? One of them has to be 0. We don't know which one. It's either A equals 0 or B equals 0. So in this case, our A and our B are going to be factors. So if you're factoring and you have something equal to 0, it's like this whole thing they're calling A, this whole thing they're going to call B. So all of that is just based on if you multiply to get 0, if the product equals 0, one of the factors is 0. That is why this does not happen when it's equal to anything else. So sometimes people will try to do this with other numbers, like if it's equal to 1, it doesn't work. Okay, so it only works with 0. So for our examples, I try to keep them the same as the book. That's why I said 1 and 2 and 4 and 6, because that's what it will correlate to. But whenever it says solve each equation by factoring, we're going to talk about this as we go through examples, but you're going to have to make sure that you factor it completely. So you're going to have to make sure you factor it all the way down. So if you have a GCF, that has to come out. If you have a special pattern, you have to make sure that you factor that. And then checking your solution, that's just something you can do with mental math. So once you get your solutions, you can always plug it back in to make sure that it works. Okay, so for A, we're going to factor 61 equals x squared minus 3. Okay, your first step is always going to be set equal to 0, and that means you have to move all terms to one side. Sometimes this is done for you, sometimes it's not. It also doesn't matter what side you move them to. I always like to move it to the side where my x squared is going to be positive because that makes it easier for me to factor. So I'm going to move 61 over by subtracting it so that I can factor. Now we should notice that 64 is a perfect square. So when you factor this, this is the difference of two squares. You have x plus 8 times x minus 8. You can always use FOIL to check. 8 minus 8 is going to be 0. 8 times negative 8 is negative 64. Now, this next step is something that you have to write out that I know is going to be so painful for some of you, but this only works because of the zero product property. So you just have to write out that it's either x plus 8 equals 0, because these two multiplied together equals 0, or x minus 8 equals 0. Okay? They can't be both answers at the same time. That is why we include them with an or. And I'm okay if it's just a one-step equation. If you just want to jump to this and not write the minus on both sides, that's fine. If you're somebody that you know sometimes makes those small errors, though, that might be something that you want to write out. Okay, so then your last step is use the zero product property to solve. Okay, so you set equal to 0, factor, set each of the factors equal to 0, and then you can solve. Okay, now for B, everything is already equal to 0, so all you have to do is factor. So I want you to factor that. Remember, the first thing you look for is the GCF. So if you can take out the GCF, we're going to do that. Okay, so Reese, tell me one thing that those have in common that I can take out. Thank you, Reese.
5.
Okay, can you tell me something besides the 5 too?
What?
Can you tell me something besides the 5 also? So what else do they have in common besides the number? Okay, so see how they both have an x in them? You have the x squared and the x. Okay, so we're going to take that out. Okay, so fill in the middle, and then Reese, and only Reese, is going to help me with that. Okay, but I want you guys to write it down on your paper. And then if you want to write each factor equal to 0 and solve, you can do that. And then Reese, it looks like you got it. You want to help me out? Yes. Okay, now when you are writing out your last step, you have two factors. This outside one, 5x equals 0, or you have the 9x minus 1 equals 0. Okay, so when you're solving this, you're dividing by 5 to get x. 0 divided by 5 is 0. Okay, for this one, the first step is to add over 1. Then you divide by 9. So then you have x equals 1/9. Okay, so then your final answer is just x equals 0 or 1/9. Okay, so for part C, we have 16 equals 64x squared. Okay, so your first step is to move everything over to one side. So don't do any type of division here. Okay, you are solving by factoring. There are multiple ways to solve this one. Okay, because the directions say by factoring, you have got to factor it. Okay, if it just said to solve and it didn't specify, it wouldn't matter to me how you solved it, but because the directions are telling you specifically to factor, we're going to move everything to one side. All right, and then we're looking for that GCF. So some of you might notice that 2 goes into both, but if you take out the 2, you still have 32 and 8. Doesn't 2 go into those? Okay, so if you took out that one, then you'd have 16 and 8. Doesn't 2 go into those? Yeah, so find the biggest perfect square that goes into that. You can use your calculator on it if you have to. Find the biggest one that goes into it. And you know you found the biggest one when the inside is no longer has any common factors. Okay, so Sam, what was your GCF that you found? Good. Okay, so if you have 16, I can't take out the x's here because the second one doesn't have an x. So I'm just going to divide. 64 divided by 16 is 4. So I have 4x squared. Negative 16 divided by 16, negative 1. And then again, you have to keep factoring. So this is where you have to make sure that you factor completely. So make sure if there's a GCF or there's a special pattern. Those are usually the two cases where you have to make sure that you factor completely. Do you guys notice anything special about the 4x squared minus 1? Yeah, you have the x squared, what else? What's this? Yeah, so it'll be the difference of your two squares. So the 4x squared is a perfect square. 1 is a perfect square. So 2x and 2x, one has to be plus 1, one has to be minus 1. Okay, now when you are solving and you are setting each one equal to 0, if you set 16 equal to 0, is there a variable to solve for? No. Okay, so there's no solution that produces. And then you have the 2x plus 1 equals 0 and the 2x minus 1 equal to 0. Okay, so if you have 2x equals negative 1 and 2x equals positive 1, we'll divide both sides by 2. Okay, so then I will get x is equal to negative 1/2 or 1/2. All right, and then I'm going to have you guys try part B. So you have 25x squared minus 80x plus 64. Okay, did we recognize the perfect squares? The 25 is a perfect square, right? That should stand out. The 64 is a perfect square. But this isn't the difference of two squares because it's not a binomial, it's a trinomial. So the first thing I would try is I would see if this is a perfect square trinomial. So the square root of 25x squared is 5x and 5x. The square root of 84 is 8, but this has to add to a negative. So what I'm going to do is I'm just going to check with FOIL. So if I have negative 40x inside and I have negative 40x outside, that's going to add to the middle, then I have factored that. Okay, now you can write this one of two ways. You can write it like this, okay, or remember how we've been writing it as 5x minus 8 squared equals 0. If you were to solve that, what would you do to both sides? Nope. How do you undo the 2? Take the square root. So if it's squared, you take the square root of both sides. And we can't forget the plus or minus, but in this case, it's 0. So if you have plus or minus and it's 0, it's just 0. Okay, so then we're going to add 8 to both sides. Divide by 5. Okay, so in this case, you only have one answer because this answer occurs twice. If you just set this equal to 0 and solve, that is fine too. Okay, and you get x equals 8/5 each time, that's fine. You don't have to write it twice if it's the same answer, okay? All right. So the next one, we have 16x squared plus 8x equals -1. I want you to do that one, and I want you to do F. Okay, so I'm going to come around and help you guys out. I don't just want you sitting here staring at the problem. We need to make sure we're trying to factor this. Okay, take another minute to finish it up. All right, so let's see how we did for part E. So once you moved everything over, be careful when you're moving something over. If you're not writing out like the +1, you should be saying that in your head, right? So we got to do the opposite. And then did you notice that you had perfect squares? 16 is a perfect square. Is 1 a perfect square? Yep. So if you have 4x and 4x, okay, +1 plus 1, you'd have 4x plus 1 squared equals 0. Take the square root of both sides. 4x equals -1, divide by 4, x equals -1/4. Okay, and then for F, you are moving your x over, so you have x squared plus x minus 12 equals 0. Now here you're going to have to do some guessing and checking. So if it multiplies to 6, you either have 3x and 2x, or you have 6x and x. So you're going to have to decide which one of those is going to be correct. And now it's equal to 0. So if you have a -12, you only have a certain number of options, right? It's either 1 and 12, 2 and 6, 3 and 4. So the most options you have 6 options for each one, like 1 and 12 or 12 and 1, 2 and 6, 6 and 2, 3 and 4, 4 and 3. Same thing with these. Okay, and then if you have a number that's small in the middle, this number is 1. If that's small, I would try to use the numbers that are closer together, because if you're multiplying something by 6, you're going to get a large number. Okay, so you're going to do your guess and check. And it is fine if you're doing that mentally, like if you put the 6 here, like, oh, that's 18, that's 4, that's not going to work. If you have 12 and 6, that's not going to work. So if you're trying these, okay, you can also think about if you have a negative, your signs have to be what? Opposite. One has to be plus, one has to be minus. So you have -8, 3 times 3 is 9, so you get a +1. If you got a -1, all you have to do is switch the signs and you'd have the correct answer. So then you have 3x minus 4 equals 0, or 2x plus 3 equals 0. Okay, and from there you can add 4 and then you divide by 3. So x is going to be 4/3, or you subtract 3 from both sides, divide by 2. X is -3/2. Okay, you need to make sure that you are showing this step. The only reason this works is because of your zero product property, so that's what we want to see there. Okay, so we're going to extend this to a story problem. So we have a 12-foot by 9-foot area that is fenced in. And then it has these walking paths along one of the long sides and one of the short sides with a uniform width of X. Flowers are planted in the remaining part of the enclosed area. The part that is covered by flowers is half of the entire enclosed area. And then it says, what are the dimensions of the area covered by flowers? Okay, there's a lot of information in there. So a good way to tackle these problems when you have a lot of information is to draw a picture of what's happening. So that's what we're going to do here. So you have a fenced in area, and it doesn't have to be to scale. Mine is not. Okay, and you know that it's 12 feet by 9 feet. It has a walking path along one of the long sides. So this would be along one of the long sides and one of the short sides. So you have like a sidewalk here. So we can make the sidewalk. Nice little path. Okay, and then what we're trying to find is the dimensions of this area. Not the area itself, but the dimensions. Okay, so there's a few things that we have to think about. The width, it said, is X, the width of this walking path. We know that this whole length here is going to be 12, because if this side is 12, this side is 12. It's a rectangular area. How can I write what this side is inside? What would this be? How can I write that? 12 minus X, good. Okay, and then I also want to write what this would be. Can you guys figure that out? 9 minus X. Okay, so we have to find the actual dimensions, so we have to find what X is. So they gave us a little more information. They said that the part that's covered by flowers is half of the entire enclosed area. So the area of the enclosed space is just going to be 12 times 9 because it's a rectangle. Okay, so we know it's 108 feet squared. So the area with flowers is what? You just have to take half of 108. So what's half of 108? 54. Okay, so the part covered by flowers is 54 feet squared because the total space is 108. What we have to do is set up an equation to find X. So we know that this enclosed space here with our flowers in it, okay, the dimensions are 9 minus X times 12 minus X. And if you multiply those together, you get 54. So we can solve for X, okay, by using FOIL, making a quadratic. You can't set each of these equal to 54. The zero product property only works with 0. There's no product property that says if you multiply these together, this one has to be 54 or this one has to be 54. Okay, so we have to FOIL. So let's do that. Actually, I'll give you a minute to do that, to FOIL. And then we'll move all the terms to one side. You can use your calculator to do that. Okay, and then what I would do is write this in standard form, so you end up with x squared minus 21x plus 108 equals 54, and then we want to get all the numbers on one side. So you have x squared minus 21x plus 54 equals 0. Okay, so we just have to figure out what two numbers multiply to 54, okay, but then add to negative 21. So we know that both of the signs have to be negative. Multiplies to a positive, adds to a negative. And our favorite factors of 54 are probably 9 times 6. That's not going to make negative 21 though. So this might be a T-chart situation, right? So 1 and 54, 2 goes in there, 27 times, 3 goes in there, 18, and then we have the 6 times 9, which you guys know. Okay, so which ones are going to add to negative 21? 3 and 18. Okay, so then when you set those equal to 0 and solve, okay, it's either x equals 3 or x equals 18. Because this is a real problem, you are going to have to plug in to find dimensions. So if you were to plug in 18, right, if you have 9 minus x, and you did 9 minus 18, what would that dimension be? Negative 9. Does that make sense? No. Okay, so 18 is not going to work. Okay, it is not a valid solution. You can think of it like an extraneous solution. You plug it back in, it's not going to work in this case because you can't have negative 9 feet. Okay, so then let's try, this was x equals 18. Now we're going to try plugging in x equals 3. So if you have 9 minus 3, yep, that's a positive value. If you have 12 minus 3, that's a positive value. So this is 6 feet by 9 feet. Those are the dimensions of the flowers. Okay, so you do have to look for what that is in